In this video, I'm going to answer some of the questions that came in. I'm going to start with Math B Essentials. I posted this video on May 16th, so this was for the prior week. And in Math B Essentials, I got some questions about the 5.1e lesson, and then I'll move into Math B Honors and go into some videos for the 7.1a and b lesson and homework. So we'll start with Math B Essentials 5.1e lesson. There was a question about picking points and whether you pick the points randomly, and you do. And I'm going to assume this question was sort of in reference to, I'm going to use slide 3 as an example, that you need to first calculate the slope for this problem, which was 10. And then to get b, you're either going to pick 1 comma 4 or -2 comma -26. And it does not matter which one you choose. And I'll just demo it just to show this. So skipping to getting the slope, and my points were 1, 4, and -2, -26. And so on this one, x and y, and just to kind of differentiate, I'll do the first one in red. So 4 equals 10 times 1 plus b. So it's y equals mx plus b. 4 equals 10 plus b. Subtract 10, b equals -6. Let's see what most people got. They got -6. Now let's try it the other way. So why did people maybe, I'm just going to predict, pick this point, which I probably picked in my video as well. Well, this point has more negatives. Even though this is technically smaller, just maybe messier numbers, because it's really, we can't say this is bigger, but just messier numbers overall. Mx plus b, y equals mx plus b, -26 equals -20 plus b, add 20 to both sides, and b equals -26 plus 20 is -6. So it honestly will never matter if you got your slope correct and you correctly go through the process of plugging your point and your slope in to get b. It doesn't matter which set of points you use. Next, we're going to go to Math B Honors, and we're going to look at the 7.1b homework and the 7.1b lesson. I'm going to actually go with the lesson first. So in the 7.1b lesson, there was a question about this problem. And in fact, if you look at most of these answers, the top few are actually incorrect. When you look at this problem and you start to do the first difference between these, you should see that the first difference is not going to remain constant. That this function won't work for all of these. For example, this would be an easy one to test. 7 times -5 is -35, plus 6 is not -125. So my guess is that people actually found this by just testing maybe for the top few points or for just some of these. And so this is actually incorrect. And this came in from the Desmos lesson. So this was a great question. And I'm going to pull up in my key, or I'll wait actually a second to pull up my key, but just look at this for a minute. So I know that this is not linear, but I know it's a function because my inputs are not repeated. I don't see -2 paired with 2 different outputs. So how do I do this? Well, there really isn't a good way to do this in Math B Honors. Maybe in high school math, you will have a technique. So you might just need to sit and stare at this for a minute and say to yourself, is there anything unique about, let's ignore the signs for a minute, 8, 27, 1, 125, and 64? Well, actually, these numbers were studied in Module 6, and these were actually perfect cubes. And notice that a negative plugged in gives me a negative, and a positive plugged in gives me a positive. And so we know that actually just through basically trial and error and looking at this, there's not really a better way to do this, that the function rule for this one is x cubed. Because if we plug in -2, -2 cubed will still be a negative number, be -8. And if we plug in a positive number, By the way, I don't know if I'm actually picking the right numbers. Did you plug in -2? Cool. All right, then let's plug in +3. +3 will give me a positive. And so how do you then go about doing these? Like I mentioned a second ago, trial and error. Or if you notice that it is a function, but it isn't linear, then they're probably going to give you something that is just a cubic or squared function. Something that is just x cubed or maybe x squared. So I would just look at your output column and see if you don't notice something about the output column. Specifically that maybe it's made up of perfect squares or perfect cubes. And then there was another question, which was from the homework number 15. And the homework number 15 was, there wasn't much to do other than to interpret what these answers meant, which is actually tricky enough. So let's see how we were supposed to kind of interpret some of these. So it said, let f of x be the number of people in millions who own cell phones X years after 1990. So X is going to be years, and f of X is going to be the number of people. So Y is the number of people. That's my output. And X is the years after 1990. So that would mean then the way that we got this answer was basically just kind of thinking about this, interpreting this, not necessarily doing any insane number crunching. So 10 is my input. That's my X. So for this one, X is 10. And f of X, or Y, is 100.3. But you can see the answer didn't necessarily have those exact values. And that's because 10 added to 1990 means the year is 2000. And 100.3, since we're supposed to interpret the outputs or the Y's or the f of X's in millions, is 100,300,000 people. And then we'll look at some of these other ones. So this one would mean this is A years after 1990, and that's what they wrote in the answer, that there will be 20 million people who own cell phones. This means 20 years after 1990 or 2010, there'll be B million people who own cell phones. And D is, so this is my X, and this is my output or my Y or my f of X. And so T years after 1990, N million people will own cell phones. This one, they tried to trick us a little bit by giving us all variables and flip-flopping it. But maybe labeling things like I just did, that this is X and this is my Y or my f of X might help. And then using this header up here or the sentence to kind of frame my answer. So hopefully that's helpful as a question came in about number 15. There was also a question which I posted in Google Classroom, if I had all this craziness, about the 7-1B homework. And I did work out these two problems, 11 and 13. So if you have not looked at those, go into Google Classroom under the 7-1B homework. And I did show some work on how to evaluate using f of X and g of X and this long expression. And then there was number 13, which used a different one, h of X. So keep posting questions. At the end of the week, I will answer them. Feel free to submit them either through Desmos or through Google Classroom or just via email.